Okay, so back to page 9. We are now looking at covalence, and hopefully you guys will take some time and go on to JLabs and practice naming, or I'm going to look for a link with just some random naming practice. It's not difficult, but you really do need to know when you're going to use ionic and when you're going to use covalent. And the best hint I have, it's not 100% accurate, but the best hint I have is if it only involves things on this side, except and including hydrogen, remember hydrogen is sort of weird, then you probably are going to need to name covalent, or even if it's just hydrogen and carbon, maybe with the organic rules. If it involves something over here and something over here, then you probably need the ionic rules. That's a quick check, and it'll get you the right answer most of the time. So when we look at covalence, we are always between non-metals. Let's remember, hydrogen is sometimes a non-metal. And we're going to use special prefixes. These are not the organic prefixes. These are the mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. The only time you're not going to use one of these prefixes is if the first atom, the first element in the thing, like CO2, we're not going to say monocarbon dioxide. We're going to say just carbon dioxide. So if it was C2O2, you'd say dicarbon dioxide, but there's just one. We leave the mono off when it's the first. We always put the least electronegative element first, and that's usually, if you think about it, fluorine is the most, sort of gets least as you go this way, so the one that's closer to the metal is most likely going to go first. So if you think like sulfur and oxygen, sulfur is a little bit less electronegative than oxygen, so it'd be sulfur oxide, sulfur dioxide. So remember I told you in class, oops, fix that typo, that is the word covalent, not ionic. We already did ionic way up at the beginning. So same thing, the less electronegative goes first, the more electronegative goes last. So then you're going to write your symbols and determine your oxidation numbers. And now these get a little tricky because, so for example, sulfur and oxygen, you would go -2. Well, sulfur is usually acting as a +6, but it can't, or excuse me, a -2, but it can also act like a +6. And in some cases, that's what it's doing.